All right, we're back at it. Hope you guys had a good weekend. Hopefully these videos by me are helping out a little bit more than just random videos on YouTube. They seem to be helping a little bit more based on the surveys I've been giving out. Which again, this week you're going to have a survey, easy 5 points every week. And just do that along with the assignment. You'll be good to go throughout the remainder of this quarantine time. So, moving on to equations with radicals. Our equations this week are only going to have square roots to them. So think about how you would undo a square root. You would square both sides. And you'll see that in the steps here. Step number 2, actually. So we'll be looking at that this week. We may look at cube roots next week. This may be it. I'm kind of deciding things as we go. So this may be the last thing we look at radicals. We'll kind of see. But with that said, let's take a look at the steps. So the first thing we need to do, you could have 1 or 2 radicals within the equation. You're not going to have 3. Mostly you're going to have 1. But you need to isolate that 1 radical on one side of the equation. It doesn't matter what radical, it doesn't matter what side, it just needs to be by itself. Once the radical is by itself, you square both sides of the equation to eliminate the radical. Now there may be some foiling involved. You just got to remember to square your numbers and all that, and you'll be good to go. Step 3, you simplify, so you get like terms all together and all that, and then you're going to solve as you would any equation. So you're either going to be left with a linear equation, so you got to get x by itself, or you're going to be left with a quadratic where you have to factor. And then here's the most important thing, you have to check your answer. Alright, we can have what's called extraneous solutions again. Remember that from rational equations? We have the same thing here with radical equations. We can have extraneous solutions. So when you plug in your answers, you cannot end up with a negative underneath the radical. And another scenario you cannot have is you cannot have a radical set equal to a negative. I'll explain each of those when they pop up, if they pop up. You are allowed to have negative answers, so I don't want you thinking that. It's just if your answer makes certain things negative, we got to watch ourselves. I got 6 problems I want to look at. The very first one is very quick, very basic, and we'll go from there. So let's jump into the examples. So first one, like I said, very basic. Square root of x equals 5. As basic as we can get. Radical's already by itself, it's isolated, so I just go ahead and square both sides right out the gate. So I square both sides, square of a square root just knocks out the radical, so you get x equals 25. We get our answer. There's nothing to it on that one. Alright, you're not going to see any more like that, but I just wanted to start out with the basic one as I usually do. Check your answer, plug it back in, it works out in this case. Next one, square root of 3x plus 1 equals 4. Radical is by itself. Now there's a lot inside, but the radical is by itself. So we go ahead and square both sides right out the gate. So we do that. You square a radical, that just knocks out the radical, so you'll be left with 3x plus 1 on the left side. Then you square 4 to get 16. Make sure you actually square that number. That gets forgotten from time to time. And then from there, you just get x by itself. Subtract 1, divide by 3, you get x equals 5. When I plug in 5 back into the x in the problem, I get 15 plus 1, I get a positive 16 underneath the radical. I'm good. Alright, my answer works out. Like I said, I'll really point out when it doesn't work. In the notes you'll see just no pointing out of answers that do work. Next, gotta get these steps hidden. Now, this one, the radical is not by itself. That is the first thing we have to do. We have to get the radical by itself. So I have here, I just rewrote it, but I boxed in the radical. So we got to get the radical by itself. So all I do is subtract 4, then I'm going to end up dividing by negative 2. You're going to see those in these steps right here. My radical is now by itself here in the green. Alright, this is where we were on problem number 2. I just subtract 4, divide by negative 2. I cannot touch the radical at all within there. Now I square both sides. Nothing crazy on the left, it's just 2x minus 3. Make sure you square the 7, so you get 49. Then you end up getting x by itself. Alright, add 3, divide by 2, get x equals 26. Check your answer. You're going to end up working 26 times 2 minus 3. You end up with a positive underneath the radical. That's all you're worried about. Alright, so looking at the second half of the problem there, if you need to. Next one. Halfway through our examples already. Now, this one we have two radicals, but they're already both by themselves on each side. So this one actually ends up being a little bit easier than you would think just at a glance. You just jump right into it and you square both sides right away. Alright, and all that does is get rid of the radicals on both sides. So you just have 5x minus 1 equals 2x plus 8. That's it. Now you get x on one side. You do whatever you want. Normally, especially in class, I would show this being done in one step. Here I'm doing it in multiple steps. So I'm subtracting the 2x over here. I like my x positive, so I get 3x, and then minus 1 equals 8. Add 1 to both sides. 3x equals 9, divide by 3, x equals 3. Alright, so we have that answer. We check it out. Plug it into both, you're going to see that you're going to end up with positive numbers underneath each radical, and it checks out. Alright, those ones end up being easier than they look right out the gate. These are the only types that you're going to see two radicals on. I could dive into it a little bit deeper, but we're just looking at pretty basic ones for these radical equations. Number 5. Now, here comes some factoring. So on this one, you notice the x is already by itself on the left, or sorry, the radical is already by itself on the left side. So we can just jump right into it and square both sides. But here's the thing. When we square the right side, we get an x squared. So since we have an x squared, I'm making note of that here. Since we have an x squared, we have to get everything to one side to get ready to factor. Alright, that x squared is not going anywhere, so I'm going to go ahead and move everything over to the right. My x squared needs to be positive to factor, so that's why I'm moving everything over to the right. Even though the majority of stuff is on the left, x squared is positive on the right, so I'm moving it over to the right. Notice I'm not adding it to anything here, so it just becomes plus x minus 2. I go ahead and factor that. If you guys recall, it's factors of negative 2 that add up to 1 in the middle. We get x plus 2 times x minus 1. We get two possible answers. We get negative 2 and 1. If we plug both those in, so notice I'm going to show you how negative 2 doesn't work. So if I plug both those in, negative 2, I get a radical set equal to a negative 2. I can't have a radical set equal to a negative. Alright, and I made note of that here. So negative 2 does not work. If I plug in 1, I'm good to go. My only answer on this problem is x equals 1. Somehow you have to tell me that 1 is your only answer that works. Whether you box in like what we did with rational equations, you can do that. You can box in both of these, but just have negative 2 crossed out if you want. I don't care. Or just rewrite it like this, like I have x equals 1 here. It's completely up to you. But make sure you're checking your answer here. Alright, so be careful with that one. Last problem. Now, we really got to watch ourselves here. Radical's still by itself, so we're just going to jump straight into it and square both sides. So we're okay there. But the left side's what I need you guys to watch. We have x plus 3 on the left side. So we square both sides, but I need to FOIL the left side. X plus 3 squared means x plus 3 times x plus 3. So when you FOIL that, first, outer, inner, last, you get x squared plus 6x plus 9. Just like the last problem, we have an x squared, so we've got to get everything over to one side and factor. Factoring is going to be pretty basic. Alright, you've already seen pretty basic factoring these last two. Subtract 4x, subtract 8 from both sides, we get plus 2x plus 1. What factors of 1 add up to 2 in the middle? we get x plus 1 times x plus 1. We only get one distinct answer, which is negative 1. Again, negative answers work. You plug it back in, you can kind of see it here, just so I can see most of it. Negative 1 plus 3 is positive 2, so I get equal to a positive, so I'm okay. Then I got to make sure I'm underneath the radical is positive as well. 4 times negative 1 is negative 4, plus 8 is a positive 4, so I'm okay on both sides here. So I just get one answer. So that's what we got here. So those are my 6 examples. I got a worksheet for you. I'm going to give you the answers again. I need to see the work. You're going to have a survey, and that'll be all that we have this week once again. So this will be, like I said, pretty standard moving forward through the end of this remote learning, however long this lasts. If you guys have questions throughout the week, let me know. And that's about it. We'll see you guys. I'll talk to you guys when I talk to you. All right. See you.